So in this lesson, we're going to take a look at how molarity can be used in stoichiometry calculations. So in stoichiometry calculations, we were given the mass of reactants, of either one of the reactants or both of the reactants, and we were asked to determine the mass of the product. And what we needed to do with those types of calculations is we needed to look at which of the reactants was the limiting reactant, and then from there we could determine how much of the product was produced. So we're going to take a look at how molar concentrations can help us solve our stoichiometry problems. Remember, molar concentration is equal to C equals N over V, where C is the concentration that's calculated, in moles per liter, which can be abbreviated molar. N is equal to the number of moles, and V is equal to the volume. Now remember, this has to be in liters. Moles is in moles. Okay, so if you're given milliliters, you always need to convert to liters in order to use this particular formula. Now remember, in stoichiometry, we looked at chemical reactions, and we had a chemical equation that we needed to ensure was balanced. And with stoichiometry calculations, we always have to use a molar ratio, or a mole ratio, pardon me, involved using the mole ratio between reactants and products. And usually we are trying to determine mass, so we also need to look at a molar mass conversion factor, plugging that into our calculation. So involve using the mole ratio between reactants and products. In addition, molar mass is often required as well. So if we're looking at a mole ratio and molar mass, and we're given information about the concentration of solution, what would be valuable to us then is to calculate the number of moles of a particular reactant we have, and then plug that into our stoichiometry calculation. So the oops, sorry about that, not paying attention here. So the equation that we're going to use, so to solve for moles, N is equal to C times V. So in stoichiometry calculations, it would be useful for us to have the number of moles of a particular reactant that we're working with. So if you're given the concentration and you're given the volume of solution, you can calculate the number of moles. Just remember that your volume has to be in milliliters, so don't forget to your volume has to be in liters, so don't forget to convert from milliliters. Also, if one of your products is a gas, or one of your reactants is a gas, your conversion factor, remember, at STP, so at standard temperature and pressure, 1 mole of a gas is equal to 22.4 liters. Okay, but that's only at standard temperature and pressure. So let's take a look at a couple of problems that we have. Got some leftover writing here. Just erase that. Sorry about that. So we have calcium carbonate and hydrochloric acid are reactants. We're mixing them together and we're producing calcium chloride, carbon dioxide, and water. We want to know in this particular question how many grams of calcium chloride, so this product, will be made when we have 100 milliliters of a 0.5 molar HCl, hydrochloric acid solution, and we're reacting it with excess calcium carbonate. So you can see that we've got volume and we've got concentration. So looking back at our equation, concentration, volume, we can figure out the number of moles of hydrochloric acid. So that's our first step. So number of moles of hydrochloric acid is equal to N is equal to C times V, which is 0.50 m times, remember, convert milliliters to liters when you're using this equation, so 0.100 liters. When you plug those numbers in, that should give you 0.05 moles of HCl. So this is the number of moles of HCl that we have that we're working with. So we want to go from moles of HCl to grams of calcium chloride. So we're going to set up our calculation. So we want to go to grams of calcium chloride. And we're starting with moles of HCl. Alright, so if you remember from our stoichiometry unit, when you are going from moles to grams, we need to look at the conversion factor, and the conversion factor can be obtained from the equation when you're looking at the mole ratio. So let's take a look. So we've got a mole ratio of 2. And there's no number, no coefficient in front of calcium chloride, so that would just indicate 1. So we have a mole ratio of 2 to 1. Now you'll notice that I wrote the compounds, and the reason that you should be doing that is so that you can make sure that you set up your conversion factor properly so that it's canceling out the variables that you want to cancel out and leaving what you want it to leave. Now we want to go from moles to grams, so that's where we use our molar mass. So 1 mole of calcium chloride is equal to, you can calculate that using your periodic table. So you look up the atomic mass of calcium, which is 40.1. Look up the atomic mass of chlorine, which is 35.5. There's 2 chlorine atoms in this particular compound, so you're going to have to add it twice. So 40.1 plus 35.5 plus 35.5 would give you a molar mass of 111.1 grams. You'll notice that the moles of calcium chloride cancels out, so now the units that you're left with is grams of calcium chloride, which is what we wanted. So plugging those numbers in, 0.05 times 111.1 grams divided by 2 would give you 2.8 grams of calcium chloride, which is what we were trying to determine. So grams of calcium chloride, grams of calcium chloride. So you can see we went from 100 milliliters of a 0.5 molar solution of hydrochloric acid to the grams of calcium chloride. So you're given information about the reactant, you use that information to figure out the moles of hydrochloric acid, and then you plug that into your stoichiometry calculation to figure out the grams of calcium chloride. So let's take a look at a couple more problems. So our next problem, if we have 200 mils of a 0.5 molar hydrochloric acid solution and we mix it with 150 milliliters of a 0.35 molar calcium carbonate solution, what is the limiting reactant and how much calcium chloride is made? Okay, so here we're given lots of information. So let's take a look at what pieces of information we have. So I'm just going to keep my colors the same here. So green. So we've got a little bit of information about hydrochloric acid. We're trying to figure out how much calcium chloride we have, and we have a little bit of information about the calcium carbonate. So if you remember from our stoich unit, when you're figuring out which is the limiting reactant, you need to figure out how much calcium chloride is made from this reactant, how much calcium chloride is made from this reactant. So you need to figure it out for both. So it's a little bit of work. And you look to see which reactant makes the least amount of product. So the product that is least amount would be your limiting reactant. So you do have to do the calculation for both, unfortunately, so it's a little bit of work. But here we're given volume and we're given concentration for both of our reactants. So again, we need to use our molar concentration formula. So we're going to solve for moles first, so N is equal to C times V, and then we'll plug that number into our stoich calculation. Alright, so why don't we work with HCl first, since it's the first one given. So we want to figure out the moles of HCl. So N is equal to C times V, which is equal to 0.5 molar solution times 0.2 liters. Okay, remember, convert the milliliters into liters, and that will give you 0.1 moles of hydrochloric acid. Okay, so now we're going to plug that into our stoich equation just like we did in the previous example. So number of grams of calcium chloride is equal to 0.1 moles HCl. Going back to our equation, looking at the mole ratio again. So our mole ratio is 2 to 1. So we'll plug that in just like we did in the previous example. And then we have to use our molar mass, which we calculated in the previous example, so 111.1 grams. And again, it's really important that you write everything out in order to not make any mistakes, because when you cancel out your units, you can see whether you've set up your conversion factors properly. You can also see whether you have the right compound that you're working with. So there's a lot of silly mistakes that are made just because sometimes we get lazy and we don't want to write out the compound. So it's really important that you do that to make sure that you have set up your conversion factors properly. So you plug in those numbers, 0.1 times 111.1 divided by 2, you end up getting a 5.6 grams as your answer. So 5.6 grams calcium chloride. Now that's with a 200 mils of a 0.5 molar HCl. So that's with our HCl. Okay, so this is with HCl. This is how much we get. Okay. Now we have to figure it out with calcium carbonate. So this is our other reactant. So do the same steps, but now you're working with the numbers that you're given for calcium carbonate. So moles of calcium carbonate, N is equal to C times B, which is equal to 0.35 molar times 0.150 liters is equal to 0.0525 moles of calcium carbonate. Now you'll notice that I leave all the numbers in there. You don't have to write all your numbers out, but leave them in your calculator. Don't do your rounding until the very last step. A lot of times students will round along the way as they're doing their steps, and that throws all of your numbers off a little bit. Okay, so you want to leave all your numbers in the calculator and then round at the very last step. Okay, so now we're going to do number of grams of calcium chloride, and we have the same same conversion factors that we're going to use. Oh, well, actually, no. Let's take a look at what conversion factors we're going to use in our equation, because we have to look at the mole ratio. Okay, so let's take a look at what color did we use? What highlighting color? Oh, a yellow. Okay. Oh, I mixed it up. All right, so let's erase this. All right, use yellow. Okay, so calcium carbonate, no number in front here. Calcium chloride, no number in front here. So that indicates a 1-to-1 ratio. This is example number 1. Sorry if that was confusing. So if you thought that that was, yeah, right here. So this is example number 1. Didn't make that any better. Oh well. Yeah, there wasn't a coefficient in front. So there's a 1-to-1 mole ratio. So it's a little different. So we're not using this conversion factor. We're using 1-to-1. So 0.0525 moles calcium carbonate have a 1-to-1 ratio. 1 mole of calcium chloride over 1 mole of calcium carbonate. Now the molar mass would stay the same because we're still figuring out how much of the calcium chloride product we're producing. So now it takes a little while to write everything out, but it is worth it, trust me. Okay, so moles of calcium carbonate, that cancels out. Moles of calcium chloride, that cancels out. You're left with grams of calcium chloride. So when you plug those numbers in, 0.0525 times 111.1 divided by 1 ends up being 5.8 grams of calcium chloride. All right, so you used yellow for that. Okay. So calcium carbonate reactant produces 5.8 grams of calcium chloride. Well, looking at our two products that are produced, you can see that 5.6 is less than 5.8. So that means that HCl is your limiting reactant. CaCO3 is your excess reactant. So the question was asking us, what's the limiting reactant and how much of the calcium chloride is made? Okay, well, our limiting reactant is is hydrochloric acid. And the amount produced is 5.6 grams CaCl2. So this is our answer. Limiting reactant, HCl. Calcium chloride produced is 5.6 grams. We're going to do one more example here. So example number 2. In this particular reaction, we're looking at a neutralization type of reaction. So we have an acid and a base produces a salt and water. So again, we are trying to figure out, okay, so we're figuring out the amount of water that's produced, the grams of water. So that's our product. We are given 50 mils of a 2 molar solution of NaOH, so sodium hydroxide, and we're given 50 mils of a 1.5 molar solution of phosphoric acid. So we want to figure out how many grams of water is produced. Well, it doesn't say in the question, but in this type of question, you have to figure out which of the reactants is limiting. So we have to do exactly the same steps that we did in example number 2. Determine how much water is made from the sodium hydroxide, how much water is made from the phosphoric acid, and then which one produces the least amount is the limiting, and the limiting will actually determine the number of grams of water that's produced. Okay, so looking at our equation here, well, why don't we start with sodium hydroxide since it's given first. So we want to figure out moles of sodium hydroxide. So we're going to use N is equal to C times V, which is equal to 2 molar times 0.05 liters, which is equal to 0.1 moles of NaOH. Okay, so then plugging that in, number of grams of water is equal to 0.1 mole of NaOH. So we need to look at our mole ratio in the equation. So here's our NaOH. And here's our water. So we have a 2:2 mole ratio. So even though it cancels out, it's a good idea, like I said, to write it in, just to make sure that you've got your conversion factor set up properly. The units are canceling out. Alright, so we're figuring out the molar mass of water. So if you, on your periodic table, look up the atomic mass of oxygen is 16, atomic mass of hydrogen is 1. There's 2 hydrogens, so our molar mass for water is 18 grams. Right, canceling out our units. Plugging in our numbers, 0.1 times 2 times 18 divided by 2, so these actually just cancel out. You don't even have to plug them in. You're going to have 1.8 grams of water being produced. So this is how much water is produced with sodium hydroxide. Alright, now we want to see how much water is produced with the phosphoric acid. So going through the same steps. So moles of H3PO4 is equal to N equals C times V. 1.5 times 0.050. Same volume. Again, don't forget to convert your milliliters into liters. Ends up being 0.075 moles. Alright, and then number of grams of water that's produced from the number of moles of phosphoric acid. Alright, so we need to look at our mole ratio in the equation. So we've got nothing in front, so no coefficient in front of the phosphoric acid, and we've got a 2 in front of the H2O. So there's a 1:2 ratio that we're going to plug in, so that's our conversion factor. So 2 moles of water for every mole of H3PO4. And then we've already figured out our molar mass for water is 18 grams. So canceling our units. And when you plug in those numbers, so 0.075 times 2 times 18 ends up being 2.7 grams of water. So this was with our, just looking to see what highlighter I used. Okay. So with the phosphoric acid, we produced 2.7 grams of water. 1.8 is less than 2.7. This produces less, so this is our limiting reactant. So our limiting reactant is sodium hydroxide. It doesn't ask that in the question, but it does ask us how much water is produced. So our answer would be 1.8 grams H2O produced. All right, and then one last example. Now, this is how much we produce. So theoretically, that's how much we produce from our stoichiometry calculation. When we do the lab, however, we only produce 1.2 grams of water. So we want to know what the percent yield. So remember, percent yield is equal to actual mass. So the actual mass would be the mass that you measure in the lab once you've reacted those two reactants together over the theoretical that you predict from your calculations. And then we times it by 100 to give us a percent. So 1.2 grams divided by 1.8 grams times 100 ends up being 66.6 repeating, 66.6 repeating, which we could round to 67. I think there's only two sig figs. Yeah, we're given 1.2. So there's 2 sig figs, so your answer would be 67%. All right, so you've got 2 skill testing questions here. Barium hydroxide plus hydrochloric acid, another neutralization reaction, producing barium chloride and water. You want to figure out the number of grams of water. You're given the volume and concentration of each reactant. So again, you're going to need to do that calculation of the number of grams of water produced for one reactant and then do it for the other reactant. Look to see which produces the least amount of water, least amount of product. That's the limiting, and then you can answer that question. Percent yield question. So you're given the percent yield. You would be figuring out the theoretical from your part A. So then you need to figure out what the actual mass is. So you're just manipulating the variables. So instead of figuring out the percent yield, you're figuring out the actual mass. So you'd go percent yield times theoretical mass. So when you've done your skill testing questions, come on up and get them checked out, and then you'll get today's assignment.